Okay, it's 1 o'clock again on a Tuesday. That means it's time for our next HDF clinic. And I think it's number 14. There was an error in the numbering on the sign-up sheet. So I think I corrected that. It's number 14. And there weren't any questions so far, but I'm going to pause here as always. And for people who have joined online, if anybody would like to ask a question, then speak up and we'll try to find answers to your questions. Are there any questions right now about anything HDF5? No? Okay, good. That's fine. There might be other questions later. I'll just go through our usual motions, talk about last week's highlights, and then we have some interesting material, of course, prepared in addition to that. Quick announcements, not much changed here. We have an interesting webinar coming up this Friday at 11 o'clock Central about using HDF5 in AWS in the context of AWS 3. I'm sure that's going to be a very interesting webinar. And then keep in mind, we have our HDF users group event later in the fall, and the deadline is June 1st, which is now approaching fast. So you got about 3 weeks if you'd like to present a paper or have a paper and a presentation and so forth. So keep that in mind, and I'm sure it's going to be an interesting event as it was last year and so forth. I can quickly go over some items from the forum, unless there are any questions about HDF5 for people who were joining maybe a few minutes late. Are there any questions? No? Okay, good. Then I will just jump in and go over a few items in the forum that stood out to me. First of all, there was a post, somebody pointed out that there is now a re-implementation of zlib or parts of zlib available, and that person, I have the link here, so you will find it in the notes that will take you to the forum post. I forgot the person's name, but he or she pointed out that the implementation seems to work just fine as a drop-in replacement with HDF5. And as everybody knows, the source code distribution and also the binary distribution, zlib is one of the filters, one of the compression filters that sort of ships out of the box, and it uses a, I forgot whose implementation, but interesting to know that there is now a new implementation, and according to that post, there are some claims as to that the performance is a lot better. And of course, for us as HDF Group, I don't know if we will change a lot about this, but it would be interesting to do some testing. So is it really, and it probably is valid, can you decompress existing zlib compressed data sets or groups and things like that with this new implementation, do all the validation test paths and so forth. So you definitely want to do due diligence with an adventure like this. But then, hey, the easiest way to support that would be to just create a dynamic plugin, and then people can choose whether they want the built-in zlib or try maybe this new implementation. But anyway, it's great to know that this is out there, and yeah, definitely worth looking into. The second thing, there's a little bit of discussion around reference manual and Doxygen, the implications. I put here the latest link. There was sort of this discussion, or is this discussion ongoing, about how will we maintain that if it's tied, the documentation is treated like code. So does that mean that bugs or mistakes in the documentation? Do we treat them like bugs in the source code? I personally think we will. But then, of course, this then is the question, okay, if you have a particular version, 1.8 something, 1.10 something, and so forth, will that be fixed in the version where the error occurred for the first time, or will this be included in the next maintenance release? And those are interesting questions to discuss and to decide. And then, of course, some of the documentation, of course, like the reference manual, may include elements that are very specific to a particular major release of HDF5, in some cases minor release. And but then, of course, there is a large a body of documentation that has not so much to do with specific releases of the library. And so I just included some links here. For example, there was an interesting presentation at one of the PyCon events where people talk about, well, yeah, how can you sort of categorize different kinds of documentations? And of course, there's the classical breakdown into task-related documentation, documentation relating to concepts in a domain, and then reference or facts. And that's known, for example, in the DITA world. But then also in newer works, people break that down into tutorials, how-to guides, explanation, reference, and so forth. So I think these are this DITA related breakdown, I think, is pretty well accepted. And then, of course, there are some nuances around tasks can be further refined into tutorials and how-to guides or user guides and cookbooks and whatnot. And I think we will have something similar for HDF5, and that documentation will, of course, also be included in the same GitHub repo based on Doxygen and so forth. And then we just have to work out how we take that forward and how we maintain that from release to release. I'm going to pause here for a moment just to ask if there are any questions, because, I mean, this is certainly interesting. It's interesting to me, but since this clinic is all about you and your questions, I don't want to miss any opportunity to see if there are any questions. Any questions? No? Okay. Then there was another interesting thread about using the MPI-IO virtual file driver and how to do the following. Typically, when people use the MPI-IO driver, they tend to do I/O to a single file to the same data set, for example. But in this case, the user was trying to use this MPI-IO BFD, but basically have multiple data sets and then have individual ranks write to these data sets separately. And that's possible too. And I wrote a little example in that thread. If you want to follow up on that, that's possible. But again, the usual etiquette, let's call it that, when you do parallel I/O with HDF5 applies, in the sense that, yeah, all processes need a coherent view of what's in the file, and so data sets need to be created collectively and things like that. But after that, you can go ahead and have individual MPI ranks write to specific data sets and completely independently and so forth. No problem there. Then there was another, interestingly enough, related to a topic that we covered just 2 or 3 episodes earlier, when we talked about the file close degree. That came up again in this post, where a user was wondering that, well, they were closing the file, but then they still had some open handles to data sets, I believe, and that seemed to work. And then they were wondering, well, is that legitimate? Is that supposed to work, or is that not supposed to work? And So interesting enough, I take that as confirmation that we pick topics that are relevant to the concerns of our users, and that was just good to see. And then last but not least, the title is a little misleading if you are using HDFQL, which is a great choice for many of you. There was a bug fixed in now that a bug that was found in HDFQL 2.3.0, and it was this array index out of bounds exception for the Java bindings of HDFQL, and that was fixed in HDFQL 2.4.0, and I think the reporter also mentioned that fix. They saw improved performance as a result of that. Okay, so those are the things that stood out to me, and we have another interesting, very interesting topic prepared for today. But before we go there, maybe once more the question: are there any other HDF5 related questions out there that you would like to bring up, that you would like to explore? Now is your time. No? Okay. Then,
hello, this is Marta. Can you hear me?
Oh, yes.
Sorry, this is my first time, so my apologies if I ask for questions that are not in the agenda. So please let me know how to proceed. I would like to.
Oh, welcome. No.
To attend.
Just fire away.
So first question is, where is the page that you are showing? I joined some minutes late. I have just to make sure that I follow the next days. There is a GitHub with your name, and I'm following the information there. But if you have that page, if yes. This is a page that you're showing that we are supposed to see, just.
Well, I think you can see my desktop. But then there is a Google document, and I'm happy to post the link in the chat. That is where, if you would like to, before a meeting, submit a question, that's where you can submit that question. So I'll just paste that into the chat window here in Zoom. So that's just a writable by anybody Google document, and you can see in the past people have submitted questions there. And then, Laurie just submitted, that is the GitHub link where whenever we have an episode like this, we just publish the sort of the meeting minutes, if you wish. There.
Okay. Okay. Thank you for the clarification. So do you address the questions that had been asked previously? So for next time, maybe I should post the questions through the email, and then how does it work?
Whatever works for you. You can post them on the forum. We will pick them up from there. You can put them into the Google spreadsheet, or if you have a question right now, that's what this is about. Of course, if it's a intricate question,
I lost my connection, but I don't know if it's mine or. Okay, now I'm back.
Audio. Okay.
Sorry, I don't know if it was my connection or your connection. I lost the last sentence that you were. We lost her. Okay.
Okay. No, I think I could hear you, and I was just saying you can submit a question through the Google document, through the forum. You can send me an email, that's fine too. But then also, if you have a question right now, of course, I will have to make up something in response. But if you have a question right now, I'd be happy to give you an answer as good as I can do here now.
Eventually, with our intention of taking too much time because you have your agenda, I have a quick question that can be addressed in the next meeting, so it's not a rush. But I like a lot your presentation last time, the part 2, and you were showing several radial diagrams that you were presenting the result. I was wondering what is the tool that you used and how did you plan for them? Is there any special knowledge? It's mainly related or eventually related, for example, with the case that you have. You just mentioned that there is HDF5 example, and maybe that example is something that we can reproduce the same way with plotting those diagrams. Or, but again, it doesn't have to be addressed now. It's just I'm preparing myself for the next clinic. And
okay, good.
So
yeah. So I believe I have not published them yet, but I just used I believe standard PyPlot to create these polar diagrams. And I will, as part of the HDF5 IO test repository, I will publish those scripts. And it's just, we would like them to be much more automated. I mean, I pretty much cobbled together the output files and the visualizations sort of as I got results from runs on different machines, but we would like to automate that. For example, that you have a script that whenever you run HDF5 IO test, you just run a set of scripts and that then create for you these visualizations, and you can just look at the pictures. You don't have to do anything extra or by hand. So that's, yeah, we will do that. And but yeah, it's just standard Python plotlib or pyplot. I forgot exactly which one.
Okay, thank you so much.
Okay, so that's coming. I'll make a note and I will have a more detailed response here, but it's coming. Yeah. Okay. If there's nothing else, then I'll hand it over to Steven. I promised you last time, and this was actually this discussion sort of was triggered also by a post on the forum that basically got us thinking about, well, more so Steven thinking about the trade-off between variable length and fixed length strings, and I'll just hand it over to Steven.
Hello there, this is Steven Varga, the author of H5CPP, non-intrusive persistence for modern C++. And today, if I find a way to share my screen, oh, here it is, and the right screen, most importantly. We'll have a presentation, a short presentation on performance measurements, and then most importantly, strings. Because one of the questions that came up on the forum was how to record part types, actually non-part types, variable length strings with an ID. And what we see on the screen, if we actually see something on the screen, Gerd, can you please confirm that?
We see the results, yes.
Thank you very much. That's what I was actually intending to do, to show the results. We see some numbers on the left-hand side, some names, and the right-hand side, some numbers with some standard deviation. And basically, this presentation will be about how I got to there and what they actually mean. So let's get to the beginning of it. The presentation will be available, uploaded on the regular presentation sites where I collect these ones. They also can be reached on my GitHub site, HDF Group mailing list specifically for this problem. So I'll speak about part types and the standard layout types and how they relate to this question, variable length strings and fixed length strings in HDF5. And what we actually can do to measure the performance or to decide which one to use in a daily case. So what we actually can see here on the screen is a path structure with a fixed length string, where we have some namespace with some compile time set, a fixed size, an ID that was actually related to the question on the forum, And here's actually the payload, the information that they're interested in. The advantage of this layout is that the data can be transferred directly and no need for a scatter and gather operation. Now, the alternative is a non-pod class that also has some meaning space and the ID identifier and the actual payload. Now, this one is an interesting case because the actual data is somewhere else. So we actually have to do an extra level of, or we are dealing with an extra level of interaction. We have to fetch the data from, in this case, the main data accessor and modify it if you want it to. This brings up the question, like, do we actually need this ID? In SQL, we actually see often that we relate different tables with an extra identifier. But in this case, we could just use an indexable container, write to a specific location with offset. The C API also has its own specific way of saying the same thing. Or for that matter, we could read it back. And it actually would reference, would be matching with the ID concept, but HDF file using something simpler, more straightforward for linear algebra users, the numerical indexing. And in this case, that here is what is a fixed length variant would look like. So how to make this type map? With H5CPP, it requires some sort of a setup, a template specialization, and within this specialization, you do your CAPI type definitions. Make sure that you don't leave unnecessary type descriptors hanging around, dangling around. And finally, you have to return the HDF CAPI type descriptor that will be closed with an REII mechanism later on. And don't forget to register the entire mechanism with this macro call, so the system will know about it. Luckily, you don't actually have to do this one in most cases. If you have post-struct types, there is an LLVM-based compiler that will do it for you automatically. In some cases, however, that's the way of doing it manually. So what can you do with it when you have these setups, when you actually can have strings in a vector or a fixed length string? So how to measure it? To actually get to the numbers that I promised you at the very beginning, requires some sort of a benchmark software. There are plenty out there. Unfortunately, most of them require some complicated setup for the HDF file system. So I wrote my own in a few lines, much similar with the H5CPP concepts with Pythonic syntax. You can pass the arguments in arbitrary order. They will do the writing. In this case, it would be nice to have some name and arguments that you can pass along, probably referring to the size or the batch sizes that you're actually saving or loading up. You may want to have a warm-up iterations before the actual sampling. And if you pass around the H5CPP type descriptors, they are just actually wrap binary equivalent of the CAPI type descriptors, then they will be reset, or whatever that means that requires to get back to the initial state every iteration, so batch iterations. And the actual juicy part is a lambda function. So there's not much to it. You receive the index within the arguments that you passed, first, second, third, and such, starting from 0, having a C-like indexing here, and the actual number, in this case, is referring to the batch size. And it returns a double. So that's what actually that arrow expression means in C++ lambdas. In this case, we are appending a string to a data set, and we return the transfer size. The transfer size has been pre-calculated, so we don't want to waste time or ticks for the calculation. Here's an example for how you would do that with CAPI. So the framework is not very useful if it actually does the job and cannot actually compare to the baseline. And the baseline is the C API, the HDF5 official API. So this is the the simple block that requires some setup in the highlighted section. It basically computes the transfer size, sets up some prerequisites such as the file names and such. All of the HDF5C API calls or identifiers are wrapped within a H5CPP binary equivalent identifiers. It's just basically like a marking the type. So you know, your software knows what to do, how to release these resources later on. It makes it rather dense code. And this is the actual juicy part, the throughput measurement, and this is how it would look like, or how it looks like. You specify the name. This is the part when you retrieve the batch size. You do some memory space marking here, where you actually using the select all, similarly with the file space, and you're making a call with H5D write, making the entire mechanism very suitable for a C-API benchmarking as well, for its H5CPP benchmarking. Now, what you actually see here somewhere the upper side is also an interesting part where you specify a chunk size. What actually happens behind the scenes is an automatic conversion between the C++ side and the C side. You can pass arbitrary H5CPP official API objects or handles to the C API if you do the right thing. And here it is. That's all about benchmarking of the C API. So what would you pass? What parameters? Definitely would be nice to control the experiment size. So this is your batches, in this case, 10,000, 100,000, and 1 million. Incrementally would be nice. A little bit of a warm up just to clear the throats, oil up the cogs, and then see what happens. And standard deviation or the residual error, we cannot really compute it within a very, it's like a single case, so we're gonna have a sample size. And it turns out this sample size increases on a simple laptop, and then your variation will be less as well. So it turns around, well, it comes up to about 5 to 10 is a good number. And of course, we're gonna control the chunk size, which is important for the internal caching mechanism, both H5CPP and the C API. And what we're looking at here was the very beginning what I showed you. These are the actual results. And you can see the total events in a column organized, the million of events per second. So it's actually timed. The total runtime that lambda function actually did with the standard deviation. There are some bits here, as you can see, and a million bytes per second throughput with the standard deviation column. There is more metrics collected, currently not reported here, but will be reported into an HDF5 file, which you can further process using your favorite software, possibly Python, to visualize it. Maybe Gerd Heber will do the funky star plot, possibly. But what we can see on this little numeric summary here is that certain operations are doing outrageously well, as we can see, and some of them are not so much. And while here we're not going into the reasons of the whys and the hows, but definitely what we can declare here is choose wisely when it comes to performance between various structures. You have to be aware that level of interactions will cost you, sometimes dearly. And that's in a nutshell. This presentation about please do choose your data representation wisely when it comes to massive scale, when latency matters to you, when throughput matters to you. And this is a really tool to help you do that. If you have any questions, please feel free to ask either here right now or on the mailing list, possibly in upcoming later HDF clinic shows. Thank you very much.
Thanks, Steven. Yeah, that looks great. If can you go back to the results? I mean, yeah, it's really it's definitely also in line with sort of the webinar, in the sense of, yeah, unfortunately, and I can't stop repeating that, it ideally it would be difficult to get simple things wrong. Unfortunately, that's not the case, because just following when we make design decisions, sometimes we just say, oh yeah, we don't really know quite yet what length of string we'll be dealing with, and we just make this a standard string or variable length string, not not having internalized that that is going to cost us a lot right there, whether we like it or not. And I guess while it might be difficult to really safeguard everything to the point that it's really difficult to get simple things wrong, I think this is the first step, or part of the first steps of raising awareness and saying there is a price tag, and here is an example what this price tag might look like.
Indeed, your questions that you brought up here are they have grounds. This is scratching the surface. This is only to show that here it is. That's where you can end up. And those constraints that you mentioned are not addressed. This is just a pilot project to lead a direction towards what happens when you don't know the string size up front. What is if you want to save an arbitrary size document and you want to do that efficiently? How to do that one the right way? So currently these numbers indicate, interestingly, rather low performance with variable length strings with the C API. And similarly, that's confirmed somewhere in with my own implementation of the H5CBB, which relies on the same cause. Probably slightly better. What's behind these numbers, and is not shown on the screen, that these ones are with warm-ups and multiple runs. It turns out with a single run of the same cause, perform interestingly better, somewhere in the 80 megabytes per second throughput, or million bytes per second throughput. That could be a significant difference. It has to do something with the updates. And I am far from saying that this test covers all the angles, because it doesn't. But more or less gives a feel what would happen if your choice is not the correct one, or not the most optimal one given your scenario.
Okay. Unfortunately, we are also out of time, but thank you very much, Steven, for preparing this. I can also see maybe we should create a polar diagram, and it will look much more dramatic than my polar diagrams, because again, you could make the same argument and say, in an ideal world, it wouldn't really matter whether you choose it this way or that way. So on the polar diagram, you would see a circle, but that obviously is not going to look like a circle at all. It will have some very deep.
I think that's a good idea, and we should collaborate on it. As this framework is intends to write all the results, and there is a lot of measurements collected here into a format. So if we standardize it some way, then we can come up with the plots of what we like. So somehow I call out to the community, to you, Gerd, to collaborate on what to measure and how to record it in a standard format, so we could have our plots. And there you have your polar coordinate system and diagrams.
Okay. Thank you very much. Thanks everybody for joining. And we look forward to having you and more questions next time. And again, as Steven just did, this is not the monologue, and we are happy to entertain your questions. But if there is a specific topic where you would like to give a lightning talk or present some materials, please reach out to me or to Lori, and you will have an attentive audience. And thanks again, everybody, for coming, and see you next week.